This lesson is isosceles and equilateral triangles. Our learning target is I can solve problems using isosceles and equilateral triangles. So some of this stuff may be familiar, and then some of it may be just things you have forgotten, or maybe you never learned it before. So here's a big deal. This is called the triangle angle theorem sum. So this word theorem just means like it's like a fact in math. So something that you always know is true. So the sum of the measures of the angles of a triangle is 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C has to give you 180 degrees. Every triangle you ever see is going to add up to 180 degrees. Okay, so you should be familiar with isosceles triangles, but let's talk about the different vocabulary things you should know. So the two congruent sides are called legs. So my legs are AB and BC, and they have that little tick mark, which means congruent. That's how I know those are the legs. The angle where the legs intercept is called the vertex angle. So B would be my vertex angle because it's the angle between the two legs. The side opposite the vertex angle is always going to be called the base. So here's my base. And then the angles along the base are called the base angles. So 2 and 3 would be my base angles. Alright, so I'm going to have one vertex angle. I'm going to have two base angles. I'm going to have two legs, and I'm going to have one base. So those are all the parts of an isosceles triangle. Okay, so here's some theorems that you need to know. So here's the isosceles triangle theorem. So once again, it's a fact in math that we know is true. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. So my example, let me draw a little triangle. So if side AB is congruent to side CB, then angle A is congruent to angle C. So converse is if you flip around the if and then part. So this is also going to be true. So if angle A is congruent to angle C, then we know that leg AB has to be congruent to leg CB. So they say the exact same thing, just flipped around. So if you know the base angles are congruent, then the legs are congruent. If you know the legs are congruent, the base angles are congruent. So let's look at this one. Okay, so we have two legs that are congruent. So if this is a leg and this is a leg, that means this is the base. And the two angles on the sides of the base are called your base angles, which are always congruent. Okay, so C and E have to equal the same thing. Also, we know that a triangle has to equal 180. So 106 plus the measure of angle C plus the measure of angle E has to be 180. If I subtract 106, I know that when I add angle E and angle C, I have to get 74. And I know that both of those are the same angle, so I'm just going to divide this by 2. And I get that both of those angles have to be 37. Because it's the only way I'm going to get a triangle that equals 180 degrees. Okay, so if I look at this one, I'm going to find X. So if I know that this angle and this angle, which are my base angles, if they're congruent, then I know that these two legs over here have to be congruent, because that's what that theorem says. So I'm going to take the two legs, and I'm going to set them equal to each other, and then I'm going to solve for X. So I'm going to move the 3X over here. I'm going to move the 73 to the other side. 96, and then I'm going to divide both sides by 6, and I get that X equals 16. So just using that theorem and applying it to problems is what we're doing. Okay, so sometimes you're going to have problems like this where you're not actually given a picture. So what I want you to do is I want you to pause the video in 3 seconds and I want you to see if you can draw the picture of the situation. So try that in 1, 2, 3. Okay, so it tells me that the triangle is named RST, and it tells me that RT and ST are actually my legs, which makes these two my base angles, so they have to be congruent. Alright, so if angle S is 13x minus 18, and angle R is 9x plus 2, and angle T, 17x plus 1. We're going to find x and the measure of each angle. So if I know that R and S are my base angles, then I know that those two are equal to each other. So I'm going to take those two expressions only and set them equal to each other. So you have to understand which ones are the base angles. Okay, so I'm going to get my x's on one side, I'm going to get my numbers on another side, and then I'm going to divide both sides by 4. So I get x is equal to 5. So I got the first part done. So now I'm going to use that number 5, and I'm going to plug it back in. So I get that angle R is 47. I could plug 5 in for the x and s, but I know that those two equal, so I can save myself a little time. And then if I plug 5 in here, I get 86. And then once again, you just want to check to make sure, just an easy little check, that when you add all 3 of them, you get 180 degrees, and you did, so you probably did it correctly. Okay, so I want you to do the same thing. I want you to pause the video, and I want you to draw the picture. 1, 2, 3. So here's my picture, and then I know that x and y are the base angles, so they equal each other. So I'm going to set those two equal together. I'm going to get my x's to one side. I'm going to get my numbers to another side. Oh, I just did that wrong in my head. Don't look at that, sorry. Okay, let's try this again. There we go. And when I divide both sides by 2, I get that x equals 18. So now I'm going to start plugging things back in. So I get that x is 78. If x is 78, y also has to be 78. And I get that w is 24. And you could just to be on the safe side, check and make sure that all 3 angles equal 180, which they do, so we're good. Okay, so now let's look at equilateral triangles. So an equilateral triangle, let me say this again. A triangle is equilateral if and only if it is equal angular. So remember, a lateral refers to sides, angular refers to angles. So here's what it's saying. If the measure of A, B, and C are equal, then side AB has to be equal to BC, which has to be equal to CA. So it's saying the sides also have to be equal. The converse of that is if the sides are equal, then you automatically know the angles are equal to each other as well. So just working back and forth between angles and sides. Alright, so let's do some problems using that. So if I know that this angle is 60, this angle is 60, remember a triangle has to equal 180. This angle also here also has to be 60, because that's the only way to get it to equal 180. So if I know all the angles are equal, I also know all the sides are equal. So that means BC is 9 feet, and AC is also 9 feet. If the angles are equal, the sides are equal. Alright, so notice you have these tick marks, which mean congruent. So this side has to be 24, this side has to be 24. If the sides are equal, then we know all 3 angles have to equal. And anytime you're talking about an equilateral triangle, all the angles are going to be 60. So 60, 60, 60. And if you add all 3 of them, they equal 180. That's how you know you did it correctly. Alright, and we're going to do this last one together. So, PQR is an equilateral triangle. You're not assuming anything, it tells you that. if I know that the sides are equal, I can just pick two, it doesn't matter which ones, and I can set them equal to each other. So I'm going to pick, let's do PQ and QR. If you picked another two, it didn't matter because they're all equal. So as long as you pick two and set them equal to each other, you should get the same answer I do. So I'm going to move my y's to one side and my numbers to one side, and then I'm going to divide both sides by 5. So y equals 12. Alright, so that's what y equals, we got it. Now we got to find what x equals. So the only thing that tells me is the measure of this one is 7x minus 3, but I know that every angle in an equilateral triangle has to equal 60, so I'm just going to take that expression and set it equal to 60. So I'm going to add 3 to the other side, and then I'm going to divide both sides by 7, so I get x is 9. So we did what the problem was asking. If you have any questions about this video, let me know and I'll try to help.